Warm greetings from Jaya School of Architecture. Today we are in the 17th session of the DECODE series. Today we do have a very interesting topic to discuss upon: artificial intelligence in architecture. We have two eminent architects, architect Varsha Anand and architect Sharath Raj, here with us to present on the artificial intelligence in architecture. Architect Varsha Anand and architect Sharath Raj are computational enthusiasts who co-founded Depth Lab, an initiative aimed to inform and experience design through computational strategy, ranging from advanced algorithms, artificial intelligence in art, architecture, research, and prototyping. I welcome both of you for the session. The stage is yours.
Good morning, everyone. My name is Sarath, and we are going to cover about the topic AI in architecture and how machine language and neural networking can help us live to help us travel further towards utopian future. So this webinar is going to be very basic. We have tried to make it very basic. So I'm skipping all the technical parts. That would take much longer. And so in order to finish this webinar within 20-30 minutes, we will keep it very brief. Yeah, so my name is Sarath, and me and my friend Varsha, we started Def Lab. Def Lab is a research and an educational laboratory which does a lot of generative algorithms and training AI and additive manufacturing as well. So let's get started about AI in architecture. So what is AI? Like, when was it started? Like, how did it happen? So AI is initially conceptualized by the computer scientists back in 1950s, when they wanted to mimic something which was very similar to our human brain, which was the most complex entity to decode back in that time. So this led to the formation of supercomputers, which in turn evolved into what we know as the AI. So an AI is based on a set of algorithms, and these algorithms form the core of the neural network for an AI. So initially conceptualized to do trivial tasks, day-to-day tasks, which the humans felt very lazy doing it. But in the recent 20-30 years, we have found that AI can visualize and comprehend unprecedented complexity which the human brains cannot do. And let us see how this growth and what led to this growth. So essentially, the human brain and the artificial intelligence, or the neural network, which it's based is basically the same, similar to the neurons. And in our human brains, we have a neural network which is a huge a data transfer center which processes multiple thousands and lakhs of data every single second. So this data crunching which the machine does is based on the algorithm, whereas our human brain is based on emotions, a lot of chemical components. So that's the core difference between these two, but they function the very same. The same. Both are basically a processing unit. So as I said, that the AI works on a different algorithm. So this we call as a logic control, and AI is based on generative and genetic algorithms, which is directly tied to a set of conditions or rules which the AI has to follow in order for it to produce precise results. And this is also important so that AI can evaluate and evolve without the help of a human. So that's exactly why AI is much superior than the human brain. The human brain needs to be trained, whereas the AI can learn on itself. So there is a lot of back and forth transfer of data between the algorithm and the conditions, the rules, and how this works, and this entire thing is called the neural network. And there are so many such conditions and rules that the AI has to follow, which we call the inputs. And these inputs, and again, another layer of data transferring between the network. It's a huge data train, like multiple data sets, which gets processed in every millisecond, so that the AI can produce the most optimum or the most efficient output which the AI thinks is the best for the given conditions. So this has a lot of we have set A, set B, and how it's processed, the whole network itself. So like, I'm not going to explain this network in detail, it's a little complex. So that's when we can understand how deep learning and which led, so like how machine learning led to deep learning, and that's what the current industrial research all about. So AI, we can see that the AI, the AI has already trickled into the basic consumer products, like all everyday products we use, the services which we use, like for example, Google. It's all the whole, with the very core of the services which we use right now is based on AI, and this was not possible, or it was beyond our comprehension 20, 30 years back when all this was new. So right now we live in an era where we are stepping into Industry 3.0, or Industry 4.0, and or the Internet 3.0, which is entirely based on AI. So, and I think this is the perfect time for us to understand how an AI works. So let's see how AI can be used in architecture on a daily basis. So let's just take the example of solar radiation analysis. So initially, so we all know that in order for you to understand how solar radiation works and the sun path diagram and stuff, and it all again involves a lot of data which are numbers which says or speaks about the heat index ratio, the regression coefficient stuff. These all can be made using a few softwares which we have, or even out of experience, like research, understanding how the climate works for a couple of months will get you close to the research which you want to do. But what if the scale of the project is big, or like for this example, for this pavilion, for example, which is a kinetic facade which reacts to the humidity and the temperature surrounding it. So it has to deal with the constant data crunching, like all the humidity value, the solar radiation values will be crunched into data, which in turn is going to be converted into a machine language, which controls the opening and the angle of deflection for the facade in every, say, a set amount of time. So in order for this to happen, we need a processing, or like an algorithm which will be able to do this. And this exact algorithm will work only for a set a surface or a set building for a set period of time and for a set location. So what if so like we have softwares like Ladybug and Honeybee, which helps us do all the data crunching, and then we'll give you the data for which we design. So this EPW, what we call the weather data file, it's an open source thing. We can get it from the internet and feed it to Ladybug, which is a plugin you use in Grasshopper and Rhino. You get all the analysis, all the numbers which we talked about, the coefficient regression, the heat index ratio, the solar map, and the angle of intensity, so that you can design your aperture the way you want it, or the facade to be more responsive to the solar radiation. But it's a very tedious task to be done on a daily basis, especially when there's constant design changes, and it's a recurring algorithm which you practice every single day, and this whole design exercise would be a 2 or a 3 day process, and it's kind of a little tedious, and the precision which we get out of the software which we have, and the the distance between getting the data to work exactly with the design language which we want is not perfect. So for this exact reason, so we thought we would train an AI which does solar radiation analysis on a surface, uh, where you can map textures in relation to the solar analysis which we have. So for this purpose, we have two networks which we train. One is a pix-to-pix based, and the other one is a cycle GAN network, which lets us study and analyze how a particular surface could be optimized for the a given solar radiation for a location throughout the year, to come up with interesting surface patterns or facade treatments, which is going to be more responsive and accurate, the most accurate. So this is an AI research which is still in process, and this is the some of the outputs which we got, and how how we train. The left one shows, the left video shows how we train the AI, the training process involved in building an AI, and the output which we get is based on the solar radiation, the original surface, and the texture with the AI produced, and the texture which is mapped on the surface later. So it is, to be honest, it's a very intense training. The AI requires very intense training in order to do perfect, to achieve precision. But once we close the gap between the training and the results, we can see that this so every new surface or any given surface can be solar optimized for in a given second. So the example which I gave you right now is a very tiny part of how AI can be useful on a daily basis in architecture. So let's see how researchers and urban designers who have been using AI to understand and study urban data. So basically, some network issues, my files are not loading. So basically, what the current research is about is that the use of a natural patterns which is available in nature, like from like all the elements which you use for biomimicry, and we study the patterns available in nature along with the urban pattern of the urban infrastructure we have, the roads and the blocks, and the districts in a city, and we match these patterns through AI, so that the result which we get from the processing would be a solution to solve an urban issue. Let's say there is a city which is tightly packed, and there's constant traffic issues and congestion. And so what AI does is it studies and analyzes this pattern and compares it with the closely relatable pattern which is available in the nature, and gives you a wider perspective of the whole the potential growth of the city in a certain few years. So this will help urban planners to plan ahead, to predict which direction the city is going to grow, and which direction the city needs additional infrastructural interventions in order to satisfy the urban need. So that is something which has been in research for quite a while, and something very interesting, and something which affects the entire lifestyle of a society or a community. And so the AI is capable of understanding such complexity which we find difficult to comprehend in the first place. And also on top of that, AI is able to predict the future of the planning. So it's a pretty amazing deal for AI. So what this has created, this complex nature, the complexity involved in artificial intelligence or the machine learning, is that so we humans, our human brain has not evolved in order to comprehend these complex data. Like we need visual stimulus and visual background for us to understand anything in real life, and it's very difficult for a human brain to just look at numbers or texture maps to understand what exactly is going on. So this complexity calls for an intervention where uh, it's easier and more malleable for to process an information into for our human brain. So this medium has created a huge advancement in the production industry and the visualizing industry. So the production industry deals with a lot of prototyping and fabrications of realizing these complex solutions which we got from the AI, and the visualizing part is where we try to understand the spatial and the volumetric dynamics of the solution which we got. So this has seen a rapid growth in additive manufacturing in the last 10 years. So I remember like 5-6 years ago when 3D printing was a small thing, where it was a very small niche where people would try exploring. And right now we have so much advancements in 3D printing where we can print plastics, glass fibers, ceramics, and concrete, and we have a lot of build structures which are 3D printed, which are more sustainable and more efficient and economic at the same time. And all this has been possible only because of the intervention of AI in production industry as well as in the visualization industry. And this calls for platforms like AR and VR, and sometimes in tandem with mixed reality, or what we call as XR. So what exactly is AR, and how can we architects use it for our benefit? So AI is basically a medium which helps you interact with the digital entity in a physical space. So we can either use it over your phone or a tablet, where you can project your digital entity onto a physical space and understand how it works, the dynamics of how this new design which you came up with using computational processing power in reality. And this has already been practiced by a lot of construction industries, where they try to understand how their design can fit into a build space. And we have softwares like Unity, Euphoria, and Unreal Engine, where it lets you do these. So let me play a small video of this application, which is based on AR, where to see how it can be used on to understand the advantages of it. So the advantage of using an virtual reality or an augmented reality, a medium to visualize your design, is that it's a very interactive process where you can see the changes you do in your design in real life, and also in a given physical space where the design is supposed to be present. So it gives the client and the user us a better idea of how this sorry, one second. Yeah, better idea on how things can work in real life. And the other one is virtual reality. Virtual reality is where it allows you to allows your digital entity to be visualized in a custom or in a set digital environment, which can also be designed by an artist or an architect. And this has the most important important element, which is going to help form Internet 3.0, which is like commonly known as metaverse, where the entire trade, the lifestyle, the way the dynamics of the social world is now going to shift digital, and AR and VR play an important role in visualizing this. And Again, AR and VR is based on algorithms which are very similar to how AI works, and you need a certain set of algorithms which are common between AI and VR, and and to be worked in tandem to form wholesome visualizing experience, and that's how uh, I think AR and VR can help visualize the complex results which we get through the AI which we train. And now that we have easy access to uh, uh, sorry, yeah. So now that we have easy access to train our own AI, we can any trivial problems which you think you might be able to solve in a more efficient way. You can always train your custom AI, which can solve it for you. So we have the resources to all these things. We have the resources to uh, to to play and help AI develop together. And we live in an era where we can conceptualize and ideate complex solution, which was not possible before, and by and generally not comprehended, cannot be which generally things cannot be comprehended by natural entities. So that this is exactly why we need a digital entity or a digital visualizing a medium like AR and VR to comprehend this complex nature. And as a part of our responsibility as a responsible society, so like we all are very excited to see how AI and computational design can help us step into the utopian future we always look forward for. And we can see it's very evident that a lot of things which was more of a speculation back 20 years back has seen reality nowadays, for including 3D printed houses, and the 3D printing in itself, like just a very expensive thing back in the day, and now it's a very common thing. So like in a couple of years, you might have own everyone might own a 3D printer. The same thing which happened to the a 2D printer which we use, like the A4 printer. Like every household has it's like a it's a uh, it's a part of your lifestyle. And similarly, 3D printing would also become a part of your lifestyle, where you have any problems, you find something interesting, or you have anything that you would like to design and create, you have the power and the tools to do it and visualize it in real life. And computational design and generative algorithms uh, has already given us the ability to work on this. So uh, very excited to see how this the immediate future, uh, and especially industry 4.0, which is completely based on AI, is going to help us redefine the lifestyle which we lead, and redefine the society we live in. So that's it about um, so I believe I've covered everything which I was supposed to cover. And there are a lot of things which I've just grazed upon, never did not go in detail about, because they all require a lot of technical data and technical knowledge, which I would be required to share with you. But for the given amount of time, I think we have covered as much as we can. And thank you for attending this webinar. Feel free to contact us anytime you want to discuss about anything, or if you have any doubts. I'm pretty sure you might have any doubts, because the it might have been a lot of data for us to process. Okay, thank you everyone. Thank you.
Thank you, Sarat sir. Thank you, Varsha ma'am. That was an awesome presentation. I know artificial intelligence is going to rule the fraternity in the near future, and this session would be definitely a kind of reading, a kind of introduction to artificial intelligence for the students, especially, and for the budding architects and academicians. I thank you for sparing your time and making this session. I thank the participants for joining the session for the day. Thank you. Thank you all.